So I'm going to be going through the calculator paper. The best way to use this video is to work out which questions you need to look through. Maybe watch a bit of the video, pause the video, try the question yourself again, and then check to see if you got it right. You can skip to questions that you need to look at, and you don't have to watch all of the questions if you don't want to. Okay, so question 1, we have this question about a simple upper and lower bounds. We are asked to find out what the upper bound of the length of the room is. Now, the length of the room is generally considered the longer side, so we're going to be looking at that 3.7. Now, we know that 3.7 was rounded to one decimal place, so we look at 3.7 and we go to the next decimal place, which was 3.8, and we could look at the one below, which is 3.6. Now, the upper bound for 3.7 is going to be halfway between 3.7 and 3.8. And this, 3.75, will be the upper bound. Anything 3.75 or up would be rounded to 3.8. Anything below 3.75 would be rounded to 3.7. So we say 3.75 is the bound, the upper bound. The next question asks you for the area. So to find the area, you can do length times width, and we're looking for the upper bound of the area. So we do the upper bound of the length times by the upper bound of the width, and this will give you an answer of 10.6875. Question 2. So in this question, we're going to use basic algebraic manipulation to solve a linear equation. The first thing we might do in this question is to add 8 to both sides, leaving you with the equation 9x is equal to 2x plus 14. Next, subtract 2x from both sides, leaving you with this equation, and finally divide both sides by 7. Okay, part 2. X divided by 11 is equal to negative 6. So to undo x divided by 11, we're going to times both sides by 11, giving you x is equal to negative 66. Part 3. We're going to, maybe if you got this wrong, maybe you should pause the video and try it again. If you're not sure why you got it wrong, keep watching. So the first thing we're going to do is add 0.2 to both sides, leaving you with 5x squared equals 0.2. Now, using order of operations, we can see that x was squared and then multiplied by 5. So to undo that, we're going to divide both sides first by 5 and then square root both sides. It's important to do it in that order. So we have to divide both sides by 5, giving you x squared is equal to 0.04. You have a calculator, so you can work that out. 0.2 divided by 5 is 0.04. And then we're going to square root both sides. When you square root both sides, there are two answers. You get plus or minus the square root of 0.04. Square rooting 0.04 on your calculator gives you 0.2. So we get the answers 0.2 or negative 0.2. Okay, question 3. Question 3 is just Pythagoras. Some people in their exam seem to forget that Pythagoras existed or hadn't revised it properly. So if you haven't revised Pythagoras, it might be worth just recalling that if we have a right angle triangle, we can take the square of the shorter sides, a squared and b squared, add them together, and this will be the square of the longer side, c squared. So a squared plus b squared equals c squared for a right angle triangle is Pythagoras' theorem. Okay, using that knowledge, maybe if you forgot about Pythagoras, you should pause the video now and try this question. Okay, so we get the shorter side squared, 27.9, plus the other shorter side squared, 37.2 squared, and that's going to be the longer side squared. When you do 27.9 squared and add it to 37.2 squared, you get 2,162.25, and then we square root that to give us the answer, 46.5. Okay, in part 2, we're asked to find one of the shorter sides. So it's good to set up the equation. We have x squared plus 48 squared equals 54.4 squared. If we subtract 48 squared from both sides, we end up with this equation. Putting that in our calculator gives x squared is equal to 655.36. square root both sides, and you're left with 25.6 as your answer for the height of this triangle. Okay, question 4. I can't really give you too much advice on this question. If you got it wrong, you should just try it again now and see if you get it right. If you did get it wrong, perhaps a good tip for any of these sorts of questions is just to make sure that your calculator display looks exactly like the expression that you're given. So make sure you use the pi button, for example. Make sure you use the fraction button. If your calculator display doesn't display fractions correctly, make sure you check the settings with one of your teachers to make sure it's in the right setting. Okay, so when you do this in your calculator correctly, you get 4.11690567 to 8 decimal places. Rounding to 3 significant figures, well, we're going to take, the answer is 4.12, and you get that by looking at the third significant figure you get this by looking at the fourth significant figure. In this case, I'll go back. In this case, the fourth significant figure is a 6, so that tells us to round the third significant figure up to get to 4.12. Okay, next. Some more linear equations, slightly more complicated than in question 2. So, for this question, we say, well, we've got 2x minus 8 all divided by 7 is equal to 3. So on the left-hand side, we have 2x minus 8 all divided by 7. So to undo that all divided by 7, we might times both sides by 7. If we times the left-hand side by 7, you're just left with 2x minus 8. If you times the right-hand side by 7, you're left with 21. The question now becomes much more straightforward. Add 8 to both sides, and you're left with 2x is equal to 29. Now divide both sides by 2, and you're left with x is equal to 14.5. Part 2. Part 2 can be done in a few different ways. I'm just going to show you one way for now. We don't really like the fractions in this question, and so we're going to try and get rid of the fractions somehow. One way to do this is to focus on one fraction at a time. So if we look at the first fraction there, 2x minus 3 all divided by 5, you might get rid of that all divided by 5 part by timesing that fraction by 5. If we times something by 5 in an equation, we actually have to times the whole equation by 5. Okay, so that's what we're going to do, times the whole equation by 5. Timesing this first term by 5 gives just 2x minus 3. Timesing the second term by 5, I'm going to write this out quite a long-winded way, but we'll simplify it soon, is going to be x plus 1 all divided by 2 all times by 5. And then times the right-hand side of the equation by 5 leaves you with 40. Okay, let's simplify that second term there in green. Okay, so we know multiplying by fractions. If we multiply fractions, well, timesing by 5 is the same as timesing by 5 over 1. We could times the numerators together and the denominators together. Timesing the numerator together leaves you with 5 brackets x plus 1. Timesing the denominators together just leaves you with 2. So that is that second term there multiplied by 5. You can just write it as 5x plus 1 all over 2, like that. Okay, so now we have 3 terms, still got 3 terms, but now only one of them is a fraction. So we're going to get rid of that middle term. We're going to get rid of the fraction part of that middle term. To do that, well, we're going to undo the dividing by 2 by multiplying it by 2. Since we multiply that by 2, we have to multiply the whole equation by 2. Multiplying this first few terms by 2, we can write this as 2 brackets 2x minus 3. Multiplying that term, the green term, by 2 just leaves you with 5 brackets x plus 1. And multiplying the right-hand side by 2 gives you 80. Okay, now the equation is much simpler to deal with. We just expand the brackets, collect like terms, and then make x the subject. So expanding the brackets leaves you with 4x minus 6 plus 5x plus 5 equals 80. Okay, maybe you should really pause the video if you haven't already. Try it yourself and then check the answer. So combining the like terms, minus 6 plus 5 leaves you with minus 1. 4x and 5x leaves you with 9x. Now we're going to add 1 to both sides, and finally divide both sides by 9, leaving you with x equals 9. Okay, so equation It's simultaneous equations, so we're going to label the top equation equation 1, second equation 2. We're going to use the elimination method. Since we have negative y and positive y, if we add the equations, we are going to eliminate y from the equation, which is what we're aiming to do. Okay, so adding 3x and 2x, we get 5x. If you have minus y plus y, you're left with no y's, and 11 plus 4 is 15. So since we don't have any y's, we don't have to write them. And if we have 5x equals 15, that means that x is equal to 3. Since we know x is equal to 3, we can sub x equals 3 into one of the other equations. In this case, we're going to sub it into equation 1. So we have 3x, and we know that x is 3, so it's 3 times by 3. Subtract y equals 11. 3 times by 3 is 9. Subtract y is 11. And so we make y the subject. We can subtract 9 from both sides, leaving with minus y is equal to 2. And then to make y the subject there, you can just times both sides by negative 1. Okay, we could check our answer here. We know that x should be 3 and y should be minus 2, but we could check that in equation 2. So, in equation 2 we have 2x plus y, and that should be 4. So 2 lots of 3 plus negative 2 should be 4. 2 times 3 is 6, plus negative 2 is 4, so we're sorted. Okay, question 7 is another right-angled triangle, so it's another Pythagoras question. Very few students got this correct, and that came from not squaring terms correctly. So a reminder, Pythagoras is a squared plus b squared is c squared. A we can say is x, so we have x squared. B we could say is 2x, so we're going to have 2x all squared. That was the most common mistake, is not to square 2x, but just to square the x. And c is root 45, so we have root 45 squared. Okay, simplifying some of these terms, we'll keep that as x squared. Now 2x all squared is 2x times 2x, which is 4x squared. And root 45 squared is just 45. Okay, so a lot of people mistakenly wrote this as x squared plus 2x squared rather than x squared plus 4x squared. Simplifying, we have 5x squared on the left-hand side is equal to 45. Now again, remembering order of operations, x was squared and then multiplied by 5, so we're going to divide by 5 first, and then square root, leaving you with x is 3 as your final answer. Okay, next question. Table of values, group data. The first question just asks you for the modal class, most common, which is this group here, the 150 to 250 group. The next question asks you for the class that contains the median. So the reasoning for this is, well, the class that contains the median is going to contain the 60th and the 61st. I'll put that in brackets because you don't necessarily need to write that. So it contains the 60th person's guess. Okay, there are 120 people who made a guess of how many jelly beans were in the jar, and so we can find out where that 60th person was, which group he was in, or she was in, and we find that there were 56 people up to 250, and so the 60th person must be contained in that group there, the 250 to 350 group. Part 3 of this question asks you to find an estimate for the mean. Okay, it did say you can use the extra columns if you would like, and that's what we're going to do. So, average. The average of something is the total number of things divided by the number. So the total number of items divided by... that's a really bad explanation. I'll try that explanation again. So it's the total number of jelly beans that were guessed divided by the total number of guesses. Okay, so there were 120 guesses, but how many jelly beans were guessed in total? Well, if we look at this first group here, the 50 to 150 group, 15 people made a guess between 50 and 150 jelly beans. We're not sure exactly what each person guessed, but we could make an estimate and say, well, let's estimate that each of those 15 people guessed 100 jelly beans. So the total number of jelly beans guessed by those 15 people would have been 1,500. Okay. In the next group, we're going to say that each of those 41 people made a guess of 200 jelly beans, and carry on. And in the final group, each of those 6 people guessed 600 jelly beans. Okay, so this is the approximation of their guess. You could also write this as the midpoint. In the next column, we could write the total number of jelly beans guessed. So for those 15 people, 1,500. For those next 41 people, 8,200 jelly beans were guessed. Then 9,300, 7,200, 4,600, 500, and 1,800. Okay, so the total number of jelly beans guessed was 32,500. Okay. And the total number of guesses was 120. So to find the average, we're going to take that 32,500, divide it by 120, and that will give you 270.83 recurring. Okay, next question is cumulative frequency. So in this table, you had to be careful. It says how many people guessed less than 50. The number of people who guessed less than 50, well, no one guessed less than 50, so you put 0 in that column. The next, how many people guessed less than 150? Looking at the previous table, it was 15. How many people guessed less than 250? Well, this is accumulating. This is the cumulative frequency. So 56 people guessed less than or equal to 250 jelly beans. Carrying on, 87 people guessed less than 350, 105 less than 450, 114 less than 550, and 120 people guessed less than 650. Now we're going to plot these upper bounds with the value. So we're going to plot 50 there, 50 naught, sorry, then 150, we're going to plot that against 15, etc. And this is a cumulative frequency diagram, so you can either draw straight lines between the points or a nice curve between the points. We're going to use this to answer the questions below. So part 1 of this says use the graph to estimate the median. So the middle person was the 60th person. You go down and you see that, I don't know, maybe his guess, that 60th person's guess was 256 or something like that. The next one is the interquartile range. So the interquartile range is the upper quartile, the 75th percent person, minus the 25th percent person. So if we look at these quartiles then, the upper quartile was the 90th person, and his guess was about 365. The lower quartile was the 30th person, and their guess was about 165, or 185, sorry. These are just estimates, so your numbers might be slightly different, but as long as your lines are correct and your cumulative frequency diagram is correct, your numbers should be similar. When you do the upper quartile minus the lower quartile, you get approximately 180. The final part says use your plot to estimate the number of guesses over 375. So if you go up 175, you see that this was the 93rd person's guess. So how many people guessed over that figure? Well, it's 120 minus 93, which is 27. Okay, next question then. The question asks you to increase 240 by 19%. I'm going to simply use multipliers rather than the convoluted method of finding 10%, then 5%, then 1%, and or whatever it is that you might have been doing. So you can just do 240 times by 1.19. So the multiplier there is 1.19 to increase it by 19%. Giving you an answer of 285.6. The next question, part 2, asks you to decrease 123.45 by 67%. If we do that, decreasing something by 67% is the same as finding 33%. So we can use the multiplier 0.33 to find 33%, and so the answer is going to be 40.7385 when you put that in your calculator. Next. The most common error in this question was to do 314.159 times by 2.65. But it's not finding 265%, it's increasing it by 265%. So really you are finding 365%, and you're going to use the multiplier 3.65. So 3.14159 times 3.65 gives you 1146.68035. Okay, next, question 10. Question 10 is about Bitcoin. It's a cryptocurrency, but you don't need to know much about Bitcoin to answer these questions. So the first part says, today one Bitcoin is worth £49.28. Today's price of Bitcoin is a fall from yesterday's price by 23%. We need to find out yesterday's price. So we're going to represent yesterday's price by this question mark. To find today's price, well, that was a fall by 23%. So we could have done yesterday's price times by 0.77 to find today's price, which is £49.28. Okay, so now that we have this equation, we can just solve it to find yesterday's price. So to find yesterday's price, you just divide both sides by 0.77, and £49.28 divided by 0.77 is 64. So yesterday's Bitcoin, one Bitcoin was worth £64. Part 2. This Bitcoin dealer bought 5 Bitcoins for £246.80. He later sells the 5 Bitcoins for £357.90. What was his percentage profit? Well, to find percentage profit, you have to find how much profit was actually made. To do that, you're going to do £357.90 minus £246.80. This gives you £111.10. To find the percentage profit, you take the profit, divide it by the cost price, so how much he bought the Bitcoins for, which was £246.80, and then to find this is the fraction, so to find the profit, you times it by 100. If you put this in your calculator, you end up with 45% as the percentage profit. A quick note here, the profit divided by the cost price is percentage profit. If you do the profit divided by the selling price, this is what we call the profit margin. So percentage profit is profit divided by the cost price. Profit margin is something slightly different. So if you got confused about that, that's perhaps why. Part 3. Another Bitcoin dealer claims that if you buy Bitcoin now, its value will increase on average by 17% every year. If you buy £500 worth of Bitcoin, how much will it be worth in 2 years' time? So if something increases by 17%, we should know that the multiplier is going to be 1.17, finding 117%, so multiplying it by 1.17. So we take that 500, multiply it by 1.17. And since this is year on year, we're going to take that and times that by another 1.17 to find out how much it's worth in the second year. We could simplify this expression to 500 times 1.17 squared. If you do this in your calculator, you get 684.45. Okay, so the next question, we're going to extend these ideas. We're going to do 500. So since it's 30 years, we're going to do 1.17 to the power of 30. And if you do that, you're left with £55,532.33. So Bitcoin seems like a sensible investment. I'm not going to do part 4 in this video, since it was just drawing a line of best fit and reading off the line of best fit. Question 11 was a tree diagram question. Now notice the important statement here that when Mary takes a sweet, she eats the sweet. So this is like questions where you don't replace things from a bag. So she eats the sweet. So there were 16 sweets available, and when Jane picks, there will only be 15 sweets available. Okay, so there were 5 lemon sherbets, 4 toffees, and 7 humbugs. Once Mary has picked her lemon sherbet, there are only 4 lemon sherbets left out of 15. There are still 4 toffees left out of 15 and 7 humbugs left out of 15. Once Mary has eaten her toffee, there are now still 5 lemon sherbets out of 15, but only 3 toffees out of 15 and still 7 humbugs out of 15. Once she's eaten a humbug, then Mary has 5 lemon sherbets to pick from out of 15, still 4 toffees out of 15, but now only 6 humbugs out of 15. Remembering with tree diagrams, we multiply along the branches to find the outcomes there. So the probability of getting lemon sherbet is going to be 5/16 times 4/15, which is 20 240ths. You might have simplified this to being 1/12. Probability of lemon sherbet toffee, again, is also 20 240ths, or 1/12. Probability of lemon sherbet humbug, 5/16 times 7/15, which is 35 240ths, 7/48ths. 4/16 times 5/15 is going to be probability of toffee lemon sherbet. Probability of toffee is 4/16 times 3/15, which is 12 240ths, or 1/20th. And we can fill out the rest of the table in the same way.
И за счет этого мой показатель не то, что смотрит, сколько денег я заработала, ты смотришь на то, какой у меня процент.
Okay, we're going to continue now. So once you've got all these probabilities filled in, you didn't necessarily need to simplify the probabilities, but you might have done. Okay, so we're going to look at this question. What is the probability that Mary picks lemon sherbet, Jane picks toffee? This is a simple reading from your tree diagram question. Probability of lemon sherbet toffee, reading from your tree diagram, was just 1/12. Work out the probability that Mary and Jane choose the same sort of sweet. Well, this is the probability that we get lemon sherbet, or the probability of toffee, or the probability of humbug. That whenever I said the word or, you may have noticed that I wrote a plus sign. So we're going to add these probabilities. Lemon sherbet was lemon sherbet I think was 20 240ths, toffee was 12 240ths, and humbug was 42 240ths. When you add those together, you get 74 240ths, which can be simplified as 37 120ths. Okay, we're going to extend those ideas, work out the probability that at least one humbug is chosen. So that's the probability of one humbug or 2 humbugs. So to get one humbug, we might have got a lemon sherbet first, then a humbug, or a toffee first, then a humbug. Maybe we got a humbug first and then a lemon sherbet, perhaps a humbug and a toffee, and finally we might have got both of them being humbugs. Looking at the probabilities from the tree diagram, we have that lemon sherbet humbug was 35 240ths, then 28 240ths for this one, 35 240ths, 28 240ths, and probability of humbug is 42 240ths. Adding these probabilities up gives you 168 240ths, and simplifying this gives you 7/10ths. Excellent. Okay, this question you could have used the table function on your calculator. If you're not sure how to use that, maybe look at the revision video on plotting nonlinear graphs, and it explains how to use the table function there. Filling out this table, you should have got these values. Most people got these values. If you did get these values and you plotted them correctly, your point should have looked something like this. And your graph should have been drawn like this. Some people would have lost marks because they didn't actually draw a curved line through the points. A nonlinear graph is a curve and should look like a curve. If you just plotted the points, you wouldn't have got all the marks there. Okay, next question. This was a difficult question. The question asks you to express 1.2 times 10 to the 3 as a normal ordinary number. That's 1,200. What is the lower bound for this? Well, we're told that speed of sound was rounded to the nearest 100 kilometers. So if we go up in hundreds of kilometers, 1,200 is what we're told was the speed. 1,300 would be 100 kilometers more, 1,100 would be 100 kilometers less. So the lower bound, if we're rounding to the nearest 100 kilometers, would be 1,150 kilometers per hour. Part 3. What is the closest the thunderstorm could have been? Well, we're told it was exactly 18 seconds. We want to find the distance, so we're going to use distance equals speed times time. Now the speed, well, this is kind of sneaky, but you are asked for the closest the thunderstorm could have been, so you really should have used the lower bound for the speed. So the lower bound for the speed, hold on, and the lower bound for the speed was 1,150. Now notice how this is in kilometers per hour. The most common mistake on this question was to do a speed times by the 18 seconds. We can't do that. We can't do kilometers per hour times by 18 seconds. This doesn't make sense. We either need to work out how many kilometers per second the speed travels at, or how many hours it takes for the thunder to be heard. So I'm going to do the latter. I'm going to look at how many hours it takes. So to find the hours, we're going to do 18 seconds divided by 60 to find the number of minutes, and divided by 60 again to find the number of hours. So it's going to be 80 divided by 3,600. Okay, this is the hours. So now we're going to do kilometers per hour times by the hours. Now this makes sense. If you do 18 divided by 3,600 in your calculator, you get 0.005. Doing 1150 times 0.005 gives you 5.75 kilometers. So the thunder was 5.75 kilometers away at its closest, the closest it could have possibly been. Okay, this question about the isosceles triangle. You know that the area of a triangle is half base times height. You don't know the height of this triangle, so you need to find that height. The height in this case is BM, which is why in the question it hints that finding BM is probably a good idea. This is a right-angled triangle, the half of the triangle that we've now drawn, BMC. So we can use Pythagoras. We know that the height squared plus that 6.9 squared is going to be equal to the longer side squared, 26.9 squared. So to find height squared, we're going to do 26.9 squared minus 6.9 squared. Putting that in your calculator, you're left with the height squared is 676, so the height is 26. This is the height of the triangle, so to find the area, we're going to do half of the base, which is 13.8, times by the height, which is 26. So we get an answer of 179.4. So carrying on with this question, we have another simultaneous equation, a pair of simultaneous equations, and in this question there are fractions which you don't really like. So my suggestion for this question would be to try and get rid of the fractions. If we label this equation 1 and this equation 2, to get rid of the fraction in equation 1, it would make sense to perhaps times the whole equation by 6. So that's what we're going to do. Maybe pause the video here and try that yourself, and then if you see a good number to multiply equation 2 by, then continue the question. If we multiply this equation by 6, we get 6x over 3 minus, well, y divided by 6 times by 6 is just y, and minus 2/3 times by 6 is minus 12/3. I'm going to simplify this now to 2x minus y is equal to minus 4. So we have an equation that's much nicer to deal with. In equation 2, we might multiply this equation by 12. I'm going to make this a little quicker. So if we times this equation by 12, we're going to get x minus 3y, and then 1.5 times by 12 is 18. Okay, now we have two equations. We'll label this equation 3 and equation 4. This is more of a standard simultaneous equations question that you might be able to complete yourself, so you might pause the video now to complete it. We might multiply equation 3 by 3 to make the y coefficients the same. Multiplying equation 3 by 3 gives 6x minus 3y is equal to minus 12. Now notice how we have minus 3y in both equation 4 and now equation 5. Okay, so we might subtract equation 5 from, or subtract equation 4 from equation 5. 6x take away x is 5x, and then minus 3y take away minus 3y leaves you with no y's, and minus 12 minus 18 leaves you with minus 30, giving you x is equal to minus 6. We're going to use this x, substitute it into, let's use equation 4, so we would get minus 6 minus 3y equals 18, adding 6 to both sides because minus 3y is equal to 24, leaving you with y is equal to negative 8. Okay, so once you got rid of the fractions in the first part of this question, it was actually just a standard simultaneous equations question. Okay, we're going to move on to the final question. If you didn't get this, don't worry. It was 3 marks, and they were fairly difficult 3 marks. So, reading the question, this postman earns £8 an hour, and he has his wages increased by £4,489 per hour. And it says that this represents a percentage increase of 10,000%. Okay, so I'm going to write the following and say, well, we take his initial wage, A, and we're going to multiply it by some multiplier. Okay, so let's look at a couple of examples to understand this question better. If it was an increase of 19%, the multiplier we would use is 1.19. If it was an increase of 375%, the multiplier we would use would be 4.75. So for this question, the multiplier, we have to work out how we get the multiplier. If it was 19%, what we might think about doing is adding 100 to 19 and then dividing by 100. Because 19 plus 100 is 119, and then divide that by 100 gives you 1.19. Similarly, for 375, if you add 100, you get 475, and then divide that by 100, and you get the multiplier 4.75. So where I've written multiplier in that purple line, I'm going to replace that with, well, the percentage increase was 10,000A. So we're going to take our 10,000A, like we took our 19%, we're going to add 100 to that, and divide that by 100. So this is our multiplier. Okay, now we can do some simplification. So I'm going to divide both those terms in that bracket by 100, leaving you with 100A plus 1. Okay, now I'm going to expand that right hand side, leaving you with 100A squared plus A. Now we can simplify. Notice how we've got A's on both sides, which cancel. So we get 4,489 is equal to 100A squared. Dividing both sides by 100 gives £44.89 is equal to A squared. And when we square root both sides, we end up with A is equal to £6.70, which happens to be the minimum wage in the UK at the moment. Okay, so that's all the questions. If there's anything you're not sure about, make sure you go and see your teacher, or you can send me an email. Thank you very much for watching.